This month, we invited Greene, who is the head of user-centered design at Satellite Applications Catapult. So she'll be talking about innovation is a team sport, how user-centered design connects user needs, technical capability, and business reality. So it's a pleasure to have you, Catherine, and I'm really looking forward to your talk. So I'll hand over to you.
Okay, thank you, Mariana, and hello, everybody. Thank you for having me at UX Oxford. It's a real privilege to be able to speak with you all. As Mariana said, I'm Catherine Greene, head of the user-centered design team, where we call it user-centered design team of service designers with various different backgrounds. And I thought I'm going to speak today about why I believe innovation is a team sport and the role user-centered design plays in connecting user needs, technical capabilities, and business realities. I'm going to cover three things. So first of all, the challenge of the space sector and why it's an interesting space to be a designer, the role of user-centered design in connecting the dots, and I'll share some case studies about what this looks like in practice. I'm aiming to come in around 30 minutes, so there's lots of time for questions. So please be thinking what those are. Let's crack on. First of all, actually, I thought I would start with a bit of background as to me and how I ended up in the space sector, because that was a little surprise to me as well. So my background is in product design. I was a user researcher, and then I moved into service design. I worked in London for over about 10 years, and I moved out to Oxfordshire and was really keen to find a local design role. And many people challenged me as to whether those actually existed. I did come across the UX Oxford crowd, and I was really looking around. And then I found this design team, and it was in the space sector, and they used the same methods, they used the same approaches, everything that I was used to doing, but it was in a space sector, and it felt hugely out of my comfort zone because this is just not technology that I ever engaged with beforehand. But I jumped in, and you know what? I surprised myself at how much I loved being in that multidisciplinary environment, surrounded by engineers, surrounded by physicists, scientists, but then also economists, impact evaluation, business strategists. So the diversity of different skills was really an eye-opener, and that's the thing I still love about it. So 7 years later, I now lead that team. We're 7 service designers at the moment, and so that's what I'm going to tell you about. So the team sits within the Satellite Applications Catapult. The Satellite Applications Catapult is a network of catapults set up to bridge the gap between research and real-world applications. And in simple terms, we help organizations take space technology and turn it into something that delivers practical, real value here on Earth. So when I joined, I quickly realized that the challenge wasn't the technology, it was connecting it to real people, real problems, and real ways of using it. So when I say space sector, you probably think, it's been in the news recently, of the Artemis mission. Maybe you think of the design of the engine or the ergonomics of the capsule or the suits they wear. But most of the work we do is about life on Earth and how space is integrated. And you are already integrated, you're interacting with space-enabled services multiple times every day. You just, maybe you're not aware of it, maybe you are. For example, in the morning, you check the weather to see if you should bring an umbrella, wear sunglasses on your way to work. This is all informed by satellite imagery. You buy a coffee. This relies on extremely precise timing signals from satellites. Without that synchronization, financial systems just wouldn't function reliably at all. Even your bus, you're quietly waiting for it to turn up. You glance at your phone or the display, it tells you the bus will arrive in 3 minutes. That information feels really immediate, feels really local, but the position data is transmitted and combined with scheduling systems on the ground, and often satellite-derived weather data is often integrated into it to make sure the predictions are more reliable. And all of that comes together to give you a simple, trusted piece of information when your bus will arrive. And then the last thing I think is worth, oh, there we go. Lunchtime, you buy a sandwich. Satellite imagery is used to monitor crop health, soil moisture, yield. It helps farmers decide when to water, what to fertilize or harvest. And ultimately, that ends up as food on your plate. So those are the types of information and data sources that we're dealing with all the time. It's already part of everyday life, but I guess the question is, why aren't we seeing more impact, or why don't we understand that more? And the core issue is how innovation actually happens in the sector. So I think that the sector is very much comes from the realm of experimentation, of scientific discovery, of the lab. And a lot of the innovation starts with the technology instead of the problem or the challenge we're trying to address. So it's all about new capability, new data, something shiny and new, let's go with that. It's developed in labs, universities, or highly specialized environments. And then the question comes later, oh, we've got this, what can we use this for? So they often start the wrong way around, and users come too late. Often there's limited understanding of who the end user is, what problem they're trying to solve, and how this fits into their day-to-day reality. So you end up with really advanced solutions, but they're looking for a problem. Thirdly, the value is hard to see. In the space sector, the infrastructure is distant. The data can feel invisible, and the output, it just feels quite abstract and often intangible, which makes it really difficult to communicate value in a way that feels meaningful. Another challenge, adoption. So even when the technology works really well, perhaps it's quite a mature technology, commercialized in other sectors, but adoption is where things break down. So barriers such as unclear use cases, lack of trust. Data trust is a big thing, and then integration into existing systems, interoperability, where there's no clear route to procurement or scaling. So innovation stalls before we realize real impact. And so I feel like the challenge isn't about building the technology that's there, it's connecting it to real users, real problems, and real routes to adoption. And that's, I believe, where design plays a really important role. So it's not just about shaping solutions, but helping define the right problem in the first place. And I'm going to share the different roles we play in doing this. I'm going to talk about how we connect disciplines, how we help to make sense of complexity, and then help to drive evidence-based decisions. So first of all, in connecting disciplines, as I talked about it, we work in really multidisciplinary environments: engineers, scientists, business consultants, policy experts. Actually, at this table here, the lady in the green is from our impact and evaluation team. That's the lady in the darker green. She's from our geospatial information team. And that's someone in the middle there, that's a member of my design team. Then you've got marketing, and then someone from the in-orbit service and manufacturing team, all there. And what are we doing? We're helping them work together. Each group comes with their own objective, sees the problem differently. And often the real challenge is just getting people to pause, listen, and understand each other. They speak almost different languages sometimes, and our role becomes the facilitator, the translator, or bridge builder. We need to make sure we're not the subject matter expert, we're helping create shared understanding. And we do this by encouraging simple, accessible language, making sure people are focused on the outcomes, and also working really visually so that people can see what other people are thinking, and that really helps. And so, yeah, we're helping people align, we're helping them prioritize, and actually, really importantly, we're helping to build mutual respect for each other's expertise. I often use this this diagram. This is the IDEO's innovation sweet spot, as a reminder to everyone of the value of diversity of thought, and the best outcomes sit at the middle there, where there's the intersection of desirability, viability, and feasibility. And it's interesting how often you have to remind people that the value is when those three perspectives are combined. And it's not just being driven by feasibility. So our role as a design team is to connect those perspectives so teams can move forward together. Next slide. There we go. So the second role I really believe in is that idea of making sense of complexity. I think I call this zoom out, zoom in. So being able to zoom in and then zoom back out again, just to make sure you're trying to see the bigger picture all the time. And we're often working in systems where the problem is really not well defined. There are multiple dependencies and competing priorities. And our role is to bring structure to that complexity, to create a clear path forward. And a big part of this is helping teams slow down so they can make sure that we're solving the right problem. So we do this by mapping systems, understanding what the inputs, the outputs are, understanding who the stakeholders are, what influences they have, and where the dependencies lie. And we often identify where the real points of tension, and that's where the opportunity lies, but also, understanding where the trade-offs and helping people come together to actually identify them and decide which ones are the most important. And then we frame these into really clear problem statements that teams can act on. As a team, we deliberately stay solution agnostic for as long as possible. We know a lot about the different technologies, but that doesn't help us. We try and maintain the perspective always on the end user, the value we're trying to create, and not get muddied by the different technologies that could solve this. So before jumping to solutions, that's just the endless mistake I feel that people in the space sector make is we jump to solutions too quickly. So best try to avoid that if we can. And there's always a balance between maintaining momentum and having enough information to make good decisions. So we try to make the assumptions really visible, and we call them out explicitly so they can be tested later. The next role or hat, if you like, is of course the driving evidence-based decisions. So once we've defined what we think the problem is, we need to test that as quickly as possible. So we move from opinion-based decisions to evidence-based decisions, and we do that through directly engaging with end users and stakeholders through, it could be interviews, it could be site visits, it could be contextual research like shadowing. It could be, there's also desk research that comes into it as well, and we work really closely with our with the other teams to get the different types of data sources in and bringing it all together. This is just one example from a project. This is a stakeholder map which shows insights derived from one-to-one interviews with stakeholders, and this helped our client make decisions such as which stakeholders to prioritize, and consequently what shape the product or service should take, and which use cases to prioritize, and then also thinking about pricing strategies. So it became a conversation tool that helped them move forward. And the really important thing is to move quickly to testing. So we're not to leave, we may have all the data, but just to test it really quickly. We often test through scenarios, through very rough prototypes, or through simple artifacts, especially because the technologies we're working with are often really abstract. And sometimes we use futures tools to help people imagine how these technologies might fit into our everyday lives. So the examples I gave you earlier were things already integrated within our everyday life. But thinking about some of the technologies we deal with are really futuristic in that they're talking about robotics in space, or space-based solar power. Those are really abstract because it's really hard to imagine what they could look like, and when that emerges, how that will affect or fit into our lives. So we have to try and use different tools to try and prompt people to think about what it could be like, and what those future needs might need to be. And also using this sort of creative engagement tools helps people imagine the possibilities, but also helps them, I think, react more honestly. It helps us kind of move before that English polite agreement or British polite agreement to what people actually struggle with. And I find it's a really great point when someone goes, no, that's absolutely not what I need, because then you're onto something, and you're onto a proper reaction and a proper need. So I'll move forward now to what this looks in practice. I'm going to start with, these are 3 recent and some of them actually current examples of projects that we're working on. So the first one is an example that I think really brings those three roles to life. This was the Geo AI Festival, and which began with a hackathon, which we ran with DEFRA, Department for Environmental and Rural Affairs, Environment, Farming and Rural Affairs, and Innovate UK Business Connect. And the aim was to support SMEs and startups to develop Earth observation and AI-enabled services in response to real government challenges. These included nature-based markets, sustainable agriculture, and spatial planning. And at its core, it wasn't just about generating ideas, it was about strengthening connections between those innovators and the public sector end users, and creating a clear path to adoption. But the challenge was significant. We had 3 days, we had 20 SMEs, and we had to move those SMEs with very early stage ideas to develop credible propositions to complex policy and environmental challenges. They had to understand the policy environment, the environmental systems. They had to navigate really knotty problems like trust in data. Return on investment is a big thing, interoperability, and also try and engage with many different stakeholders as they could. So like much of the space sector, most of these companies were starting from a technology-led perspective, and the risk was building something which may have been technically impressive but not actually useful to DEFRA or adoptable. So our role was to help them move from technology-led ideas to these user-centered propositions. And we brought together a range of stakeholders. So there was Natural England, DEFRA themselves, lots of different end users from different departments in DEFRA, forestry bodies, financial organizations, and industry partners. And we created sort of different tables so they could do quick fire user to search and discovery all around the room. So creating this direct access between those innovators and the end users, and enabling them to test ideas against those real world needs. So doing that quite quickly. And we helped, we did the program, the 3-day program we designed had a series of structured activities which allowed them to do those rapid user and expert interviews, but also think about service mapping. It may have been the first time they actually use these types of tools, helping them think about user journeys, problem framing, and help them quickly understand the system that they were operating in. So we had lots of different designers around the room, but also we had technologists as well, able to advise on the technology. So we're all working together to support these businesses to move their ideas forward. We also encouraged teams to prototype and test early, and we encouraged them to avoid the trap of wanting it to be perfect before they showed anybody. They're actually using rough concepts and scenarios to validate. And I'm so pleased to see people using sketching and before even moving to screen. That was great. You could really see the shift. Teams begin to pivot their ideas based on user feedback. They started to challenge their own assumptions that they'd come to the hackathon with, and also rethink about their service models and what would actually work in reality. They moved from trying to perfect their solutions to testing whether they should exist in the first place. And by the end of the 3 days, teams had much clearer, more grounded propositions, a stronger alignment with the user needs. And even if they hadn't managed to engage with all those users during those 3 days, they knew who they should go to because they'd done their stakeholder map and they knew where they were going next. So they had a much clearer plan and a much clearer understanding of what they needed to build in order to move towards that deployment. So I think this is a really good example of how designers helps to connect the dots, and not by owning the solution, but by creating the conditions for better decisions to happen. The second case study is called acronym EMMA. So we love acronyms in the space sector, just to warn you. There are some of them slipped into my presentation. I do apologize. So Environmental Maritime Monitoring Analytics. So the core problem here was around emissions monitoring. So existing models could estimate emissions at a fleet level, but they couldn't show how emissions behave in specific locations or how they impact those coastal communities all around those locations. And the opportunity was to enable ports, local authorities and operators to make better environmental decisions on more accurate data, so using high resolution and location specific insight. The challenge was the lack of clarity in who the users were and what decisions the system needed to support. So the system combined multiple data sources, so that's AIS data, satellite data, meteorology, oceanography, but there's a lack of clarity over, so you could have all these data sources, but why? What do we actually want to get out of it? What decisions we need to make? And how would the outputs be trusted and used in practice? So the risk was building a technically advanced system, but it didn't really fit in a real world decision making. Oh, sorry, I was supposed to click on that to show you the different data. Let's move on to the, so what do we do? So our focus was to ground the project in real world needs, engage stakeholders across the ecosystem, ports, local authorities, regulators, the shipping industry, and brought together different perspectives on how emissions data is used and where responsibility and accountability sit. We mapped the ecosystem to understand influences, decision-making structures and dependencies. And we facilitated service mapping and blueprinting sessions to show how the data flows into decisions in practice. You can see them working, first of all, in person on the table, but then very quickly moving into digital versions which are shareable, and it really helps people to kind of take ownership, so they're able to kind of start using them themselves and push it forward. And we also then conducted lots of different stakeholder interviews to validate some of these assumptions that we had. And we developed real life scenarios based on those insights. For example, real life decision-making scenarios, such as preparing evidence for a board decision or supporting a funding case. And then we used those scenarios to test whether the system would actually support real decision-making. And the shift was, the conversation moved from what the model could do, what all singing, all dancing, different data sources that it could achieve, but actually moving towards what decisions it needs to support. This is aligning technical, scientific and product teams around the different use and the outcomes, and it clarified who the key users were and the context in which they could operate. So that helped translate complex data into something that could be trusted and used, and enabled the technical team to prioritize the development and move the product away from just a generic dashboard with an overwhelming amount of different types of data towards a tool that actually supports operational and policy decisions. So that's project just finished, and we're going to the next phase now. And actually it's had quite a lot of press as well, so that's really nice to hear. The third case study, something I'm continuing to work on, is transport infrastructure monitoring. This project is part of the UK Space Agency funded Unlocking Space for Government programme. And the problem here is around inspection of railway infrastructure. Embankments, cuttings, bridges, actually most of our train infrastructure was built 200 years ago by the Victorians and before that. And the problem is it's always an issue to monitor it for subsidence, but as climate change increases, it increases the risk of subsidence with more flooding, more heat, just makes the problem bigger and harder to manage. And these inspections are expensive. They're carried out relatively infrequently because they're just people walking up and down the line. Sometimes they use drones, but actually not that often. And also they can be quite hazardous because people have to access areas that are not always safe. They have to work often quite close to live assets, live cables, and there's a real opportunity to improve how this is done. Satellite radar technology can detect really small ground movements and monitor assets much more frequently. So where it might be done every 5 years, you can get a satellite radar technology to pass over and assess for ground movement every 5 days. But despite this really amazing capability, awareness is low, there is skepticism and perception that is complex and expensive. And most importantly, it is unclear how this data could be integrated into day-to-day operations. So the risk is that the technology then it remains unused despite its potential. So our focus has been to bridge the gap between that technical capability and the operational reality. So speaking with a lot of different transport bodies, geotechnical engineers, speaking with innovation teams, understanding data specialists, and also talking about, how they manage risk. We created a shared space to explore the problem from different perspectives, and also, most importantly, let different transport bodies listen to each other and help them share their own experiences. And we use workshops and artifacts. What I mean by artifacts is sort of images and different stories or scenarios to help explore how those inspections are currently carried out, what decisions are made, and actually what the success criteria could be for something new. We shifted the conversation from what data is available to what decisions need to be supported. And we focused on those engineers. When would an engineer act? What level of confidence would they need? And what's their existing workflow? How does it currently work? And what would this be this is just another data source, adding that into that system and really thinking about that integration. So it's been a journey, really fascinating journey, but organizations, we're seeing them move from skepticism towards curiosity and experimentation. The conversation has shifted from, is this technology credible, to how can it be used in practice? And this is now something we're actively working on, developing pilots in different locations. So that when it becomes really exciting. And what we're aiming for is a clear understanding of for them to have a clear understanding of how satellite data can reduce the risk, improve inspection frequency, and support better prioritization of manual inspection. So it's not that it's replacing manual inspections, not at all, but instead of that asset being monitored every 5 years, you're saying, well, actually the higher risk areas, these are the higher risk, we know these are the higher risk areas, let's monitor them much more frequently. And then we have a system that can alert when there's an unexpected risk notified, and people can go to those sites. It just means that they're using their resources more effectively, more efficiently, and moving it from concept into real world adoption. So this is a project that we're continuing to work on for the next year, and along with various other things on the Unlocking Space for Government program. It's a really interesting program. So those are my 3 case studies. I wanted to wrap up with, I didn't imagine ending up in the space sector, but it's been a fascinating 7 years, and I'm really thankful that I did. The title of my talk has been Innovation is a Team Sport, because I believe designers are we're good at connecting the dots. We're good at connecting ideas, people. We're good at kind of walking down that corridor, bumping into someone, and making a connection between a stakeholder we perhaps just spoke about, an opportunity we heard. We're good at making those things happen and bringing momentum, I think, to opportunities. We're good at being able to see through the complexity, being able to zoom in and zoom out. And we're really good at helping teams make evidence-based decisions when perhaps there's so much data, they're paralyzed, they don't know which way to go. You can sort of say, well, this is what we know. Let's make, based on the best information we have at the moment, this is what we think we should do. And these are the assumptions we need to validate, go forward and test. I hope that you can see that space isn't too distant or too abstract. It's already embedded in everyday life. And the challenge is not building more tech, more inventing more new shiny things, but actually making the things that are already there usable, useful, and adoptable. That's really important. So I didn't imagine ending up in the space sector, but it turns out there's a real need for designers in the space sector. So if you're a designer, I hope you can now see that your skills are really important and your role is needed, and we need more designers. And if you're thinking about your next role, maybe you will think about the space sector. And there are lots of space organizations in Oxfordshire. So look out, and I think just space needs more designers. And the good news is that we are also hiring. So please connect with me on LinkedIn if you want to understand more about the role. But let's stop there. And I'm really keen to hear if anybody has any questions.
Brilliant. Thanks so much, Catherine. Really interesting case studies, like fascinating. And also, talking about the role of the designer in that multidisciplinary team. Love that.